Question number 1. A sample contains 3 different types of atom: argon 1840, potassium 1940, calcium 2040. State fully in terms of the numbers of subatomic particles what these 3 atoms have in common. Subatomic particles means the total number of electron, proton and neutron present in an atom. Now all these 3 species, that is these 3 atoms, they have the same nucleon number. That is, for argon the nucleon number or the mass number is 40, for potassium the nucleon number or the mass number is 40, and as well as for calcium also it is 40. Number 2. State fully in terms of the numbers of all subatomic particles how these 3 atoms differ from each other. Now, they have the different number of protons, so they will have different number of electrons. At the same time, their neutron number is also different. Number B. A sample of sulfur contains only 2 isotopes, sulfur 32 and sulfur 34. The relative atomic mass of this sample is 32.09. The 2 isotopes are given and their isotopic masses are also given. Calculate the percentage abundance of the isotopes present in this sample. To calculate the percentage abundance of these isotopes in the sample, let us take the percentage abundance of any of these isotopes be X. So here we have taken the percentage abundance of sulfur 32 be X. So X times 32 plus for sulfur 34, the percentage abundance will be 100 minus X times 34. And the relative isotopic mass is given 32.9. So if we work out for the value of X, then we can find that X equals to 95.5. That means for sulfur 32, the percentage abundance is 95.5, and for sulfur 34, the percentage abundance is 100 minus 95.5, that is 4.5. Number C. The electronic configuration of sulfur atom is 1s2, 2s2, 2p6, 3s2, 3p4. Identify which orbital in a sulfur atom has the lowest energy. When we do the electronic configuration according to Aufbau principle, 1s is the lowest energy and 3p is the highest energy, because according to Aufbau principle, we fill the orbitals in order of increasing energy level. So in this case, 1s has the lowest energy. Sketch the shape of a p orbital. The shape of a p orbital is dumbbell shaped. During the process of ionization, a sulfur atom loses an electron. So sulfur in the gaseous state, it will lose an electron to form a unipositively charged ion, also in the gaseous state, and for this process the enthalpy change is 1000 kJ per mole. That means the first ionization energy for sulfur is 1000 kJ per mole. Identify the orbital from which this electron is removed. Explain your answer. For an atom, whenever we are carrying out the ionization energy, we have to take out the electron from the highest occupied energy level or the outermost shell electron. Then we move gradually inwards towards the center of the atom, that is towards the nucleus of the atom. So the highest occupied energy level for sulfur is 3p, which we can see from the electronic configuration, and this happens because it has the highest energy orbital, and that means it will have less attraction to the nucleus. D1. Complete the diagram to show the arrangement of electrons within the third shell of a phosphorus atom. Now to do this, we need to do the complete electronic configuration for phosphorus. So the total number of electrons in phosphorus is 15, and the electronic configuration will be neon 3s2 3p3. That means in the 3s we have 2 electron and in the 3p we have 3 electron. So the electronic arrangement in phosphorus atom will be this. Number 2. Explain why the first ionization energy of sulfur is less than that of phosphorus. To do this question, it's better if we can have the electronic configuration for sulfur. For sulfur, the electronic configuration will be neon 3s2 3p4. Comparing the electronic configuration of phosphorus and sulfur, we can see that the 3p orbital of phosphorus is singly filled. That means in each of the orbital there is one electron. But for sulfur, if we compare the electronic configuration for the p subshell, we can see that in p subshell, in the first orbital there are 2 electrons, and in the second orbital there is 1 electron, in the third orbital there is 1 electron. So in the first orbital there is a pair of electrons which will feel repulsion, because we know that like charges repel each other. Because of that, it is easier for sulfur to lose one of the electron, and that's why the ionization energy for sulfur is less than that of phosphorus. Again, we can say that for phosphorus it is half filled. So we know that if an orbital is half filled, it is more stable. So for this answer we can write, in sulfur the electron is removed from the 2 electron in a 3p orbital, because since they are in paired form, they repel each other.